We are Team Tech Support, and let us present our software product to you. We're building an intelligent spot the difference game with a little twist in there. Instead of using the pre-designed image pairs, our games allow users to upload any images in real time, and our website would automatically make modifications to these images without the need of human intervention. In fact, our aim is that you can re-upload the same image, and our algorithm should generate a new unique image for you to spot new differences. Behind the scenes, our algorithm will first identify objects within the uploaded image before making modifications like removing or adding objects, altering their colors, and other visual transformations made possible through the use of OpenCV's tool and algorithm. As it's a web application, we'll utilize web frameworks like Flask and front-end tools like React, OpenCV.js, and CSS frameworks like Bootstrap to gamify accordingly. And with that, we thank you for your attention and hope that you'll enjoy our product once it's ready. Too much into detail for the add object stuff without seeing all this code. I can just show you the results of our when I run the Python script over here. So currently I only ran 3 objects here. The width is 20 pixels, which is pretty small, quite difficult. 0.3 dB worth of blending. I think that's quite a lot also. And yeah, so I was saying this is more like a hard mode. And so when I ran this, it gives me the coordinates over here. Which is a flower, we use flower, cat, and walnut. So when I pull up the images over here, you sort of see a bit of it already. Okay. Yeah, I think this is more challenging. We actually blend in here. So we paste the cat towards this more white area here. This is all done by our algorithm. It finds a whiter region here. Paste this over here. The other two might be a bit challenging. Here's the walnut. I think it's a bit more brownish over here. That's why I decided to paste the walnut over here. And yeah, it's definitely a bit small. So it has 20 pixels. The flower is a bit here. Yeah, because you see it over here, it's more purplish in surroundings. So you'll put it over here, and then with our degree of blending, so it's not really very obvious. So yeah, that's a main result of what we can do with our algorithm for now. Or backend transformations or image transformations for our spot the difference game. So the other 2 transformations I've actually merged it into here. So the first one is over here, expanding the contours. So once our algorithm detects an object, we will expand that object by a subtle bit, by a bit, and the other one is change color. Somewhat like change color, we're actually changing the color of the object in order to blend in better with its surroundings. So let me just show you the result of what we have done. So I've run the Python change color.py and it shows me this image here. So we use OpenCV to read into this image, and we followed pretty standard computer vision processes. So for edge detection, we usually go to the process of converting the grayscale first. I mean, this is definitely much easier because it's much better for memory, because essentially we don't really need all 3 color channels, we just need to be in grayscale. So we blur it, and after that what we do over here is we actually use an edge detection tool. There are many different edge detection tools available on OpenCV, such as Sobel edge detection, Canny edge detection, adaptive threshold, and we've experimented with all of them and realized that adaptive threshold was able to pick up the most features, but also at the same time is very sensitive to noise. So this is the result of the adaptive threshold. So for example, it was able to pick up like contours like this as an area and all this stuff through adaptive threshold. And of course, as I mentioned, it's quite sensitive, right? Like there are like a lot of dots here and here. So what we have actually done is we actually use this function called morphology. Morphology is over here. What this does is that it actually dilates all the pixels first and then erodes them. This is in order to merge small gaps within the contours, such that we are able to better form closed images. Like for example here, like this part, because you have like little dots over here, right? So what morphology helps to do is actually try its best to merge this together such that it forms an entire contour, so that the algorithm can pick it up as a closed contour and have a proper measurement of the area. So after that, this is the morph image. You can see it's sort of like merged. It's sort of like merged this area over here. So it's more more refined, I guess. After that, what we use is OpenCV's tool of fine contours. So it picks out all of this, and for our use case specific, we only want to filter areas that are within a certain, like not too big and also not too small. So we sort of set it as within 500 pixels squares to 1600 pixels squares. So all the green color ones are the ones that we have selected, and all the red color ones are the areas that are slightly too big, or the areas are too small. And then over here, we isolated all the shapes that are of good area over here. And what we do in our algorithm, we saved it into a list actually. So yeah, we actually just append them all within good contours inside this list over here. This is the area that we specified to be just nice for us to do transformations on. And then after that, back to the image, we will randomly select either one of these objects to do the transformations on. So this is our final image. Essentially, our spot the difference will just be this image, the original, and then we just paste this one here and find differences between the two. So you can just spend some time looking at this image and seeing the difference with the original image here. Okay, and so if it's not obvious, there are 3 differences altogether. First one is we actually use our expand contour function, where we actually detected this color right here from the original image, and we just simply expanded it by I think 1.5 times to like this. So the difference is subtle, but I think it's a valid transformation for a spot the difference game.